Sorry, I got dropped. Some reason my internet is unstable. Okay, so your key, get random underscore, make sure that it's get underscore random underscore bytes and specify that as 16. I'm wondering. Check your syntax, I think, maybe. And if you want to see lines, I think for Nano, you can do Alt-Shift-3. It shows you the line number. I copy and pasted, do not type the code. Okay, might be symbol. So we type some of the symbol. It might not interpret the parentheses accordingly. Yeah, sometimes coming from, another application, it might drop like the underscore, because it's different encoding system. So it's interpreting the symbols differently. I typed mine, and I checked the syntax for the script before I added it to the document. Okay, see if you have any issues. Yeah, it shouldn't generate any error. Okay. Yeah, let me know if you still run into problems with the script. So ultimately, after you run this, okay, you should have encrypted.bin. So if we check, sorry, this is so small, I gotta scroll up. So I should have an encrypted.bin here. And if I access it, I would see these symbols, right? Originally we defined secret data in our script, and for AES, this is what you would have as the output after it encrypts your plain text. So yeah, I have that file output here. And that's what we put for the file out. Okay. Let's see. Let me look at your error again. Type error, argument 2 must be bytes, not byte array. Okay. Make sure that you have, but it shouldn't, make sure that you have the B here. Generates a random byte. Yeah, we specify the byte here. For this, cipher tag, cipher encrypt, and digest data. Okay. Cipher comma tag, cipher encrypt, digest data. Yep, that's what I have there. It's possible that this is funky right here on yours. It's not able to see what that is. Let me see if there's another way. Okay, sorry. I think you can pass it with the bytes param method. Instead of using the B. I'm going to try something real quick. Let me share screen again. Okay, let's up. So instead of using this, what if we do this? Or yep, that's right. I think you can do that. I didn't like that. Let's see if it. Oh, I forgot the S. Yep. So that works, Michelle. We can see if, so if it's throwing error, we can also redefine it as this right here. So data, and we would use the bytes method, and then put in your string and then encoding. You can try that and see if that works. Looking at most probably have installed the Pycryptodome. Oh, Pycrypto packages. Okay. Yeah, so it might be that it's not able to, but if you test the import fine earlier, yeah, so you can uninstall Pycrypto and try again. So let me put in that notes right here. I did do that earlier. So yeah. So you can try that. And then reinstall these. Now, if you tested these, I mean, if it's fine, then it should be. But yeah, I think I did uninstall this earlier as I was testing through it. Okay, so I'll explain this part. So when you, after you completed the encryption successfully, right? The number 16 is really to see if you can decrypt using a different key. Because in this script, we generate another key here. which is different than the prior key. Okay, so now when you generate this, and we would then construct the key for the mode, and we're using it with the nonce or ones, then we're going to try to decrypt it. It should give you a value error. Okay, so the point is that because AES is a symmetric algorithm for encryption, it uses the same key to encrypt and decrypt. So when you decrypt, you simply take the encrypted file and you are going to open it and you're going to read it. And as you do that, you are going to use a loop to be able to access it. Then we want to generate a key, but ideally the proper way to decrypt is to share that key or copy that key. So you have to have a key file and then be able to share that key. Now we want to test it with a different key. So we generate a second key and try to access it. So as we construct the second key and we try to decrypt it, it's going to give us a value error. And so that way we know that the second key will not allow us to access it. Okay. So similar to the encryption, we would use, the only thing is that for our object here, we're going to do a file in, and we are going to pass the encrypted file and RB instead of WB because we're going to read. And for this one, also, we are going to use 1616 and -1 because we're going to loop through, and it's going to be passing the values that would represent the cipher size and the key. So let me go down here. And then if I want to print the data, I can also print data, but this is going to throw us an error anyway. So I can do Python 3 AES decrypt dot py. So here, this is going to be a value error that's raised. It could not verify the key. Okay, because we have two different keys. So that shows that our symmetric encryption works. Import error, cannot import AES from. Yeah, so that means that your so I recommend uninstall cryptography. Do that. Okay, I had to do that, and then I had to reinstall it. So uninstall cryptography. Uninstall Pycrypto. Then I think you should install these. Install. Then you should install the Build Essential. With the lib. And then try to install Pycryptodome. Module time has the attribute clock. So it removed your time module. Oh, because it uses that for the timestamp. See if you can do pip install Pycryptodome. And then test the import statement before you do the domex. And then update after you install Pycryptodome. You can always install time module, but okay. So if you test the modules, if it's fine, then you can see if you can run your script. Okay, so we talked about the decryption. And then when you get to that part, you would provide screen capture, explain why you get an error, what happens when we use a newly generated key instead of the key that was used in cryptofile. Remember that this is the metric. So for the RSA in step 18, RSA Encrypt. Oh, wait. That. So another algorithm that we would often see is RSA. And in this lab, we want to explore how to use it. So Now for RSA, where it is a PKI, so you have a public and a private key. So in this script, we are going to use crypto public key import RSA. You are going to define your plain text as secret code. You are going to generate the key, and here is your key length. So here we're using 2048. You can also use smaller size key, but they recommend that you would use 2048 and higher. And once you generate the key, you would need to export the key. And so the passphrase unguessable is going to be passed here. And we are going to use script and AES 128 CBC. This is using blockchain mode. So after we generate the key, export the key, then we would use the key to store. So we're going to store it into the RSA key.bin. Then we're going to close that file. So at this point, you would have the public key. So once you have that, you would need key. Now, in the old module, the older version of the public key module in crypto package, this method was, and in the documentation, they still have it as export underscore key lowercase. But after a few research steps, I actually found that they updated this method to export key, no underscore with a capital K. Okay. So once we have the key, we would export this key, which is a public key. Now we are going to use the private key, or we're going to read the private key. So your secret code again, and you are going to use the RSA key.bin. We're going to read it. I'm sorry, did I say the public key? This was the private. So I'm sorry, this is the public. And then for the private, it's going to read the public key. Then we're going to import in the key using the passphrase. And then we're going to use the public key to export the public key. Now, the next step is to generate the public key and store it into the pen file for the receiver and the private key in the private pen. So you see this being done on the cloud level when you're trying to connect to cloud instances. It actually uses RSA for authentication, so it would generate the public and the private key. So the script that they implement for this is going to be similar to what we see here. So we would have the private key and the public key stored as a .pen file. So here we would write the private key after we export it. So in order to store that as a .pen file, you have to export the key. Okay, and then you would store it. And we would do the same thing with the public key, is that we would need to export the key in order to write it to the .pen file. And they are two separate files. The public key can be shared or sent, okay? Whereas the private key, we are going to keep. So this shows you how you can generate RSA keys. So coming back here, let me relog back in. This is the script that I have. And then we can run it. So it prints out the public key information. Okay, and as I output it in a file, I also ask it to print. So we see that my public key in both steps is the same. Now, if we go to our directory, we should now see the PEM file. So here's my private.pem. That is for my private key. And then I also have receiver.pem. So when using PuTTY, PuTTY is the application. It also allows you to use RSA for authentication to, for the communication for SSH, and it would generate the private and the public file like this. Okay, so I really think that your Pycryptodome is not functioning. Let me see. Okay, so let's try the instruction from their documentation. You can run those and see if it's working. Let me see if there's any alternative. I had to uninstall it a few times. I uninstalled cryptography, and then I uninstalled Pycrypto, and then I reinstalled like the steps that's shown in the lab, which is step 10, and it worked for me after that. And I had to push updates a couple of times. So you can try the step that I put in the chat. But let me find out. I did pip uninstall Pycrypto, pip uninstall Pycryptodome, pip install Pycryptodome. Okay, good. All right. So it worked. Yeah, sometimes when you uninstall it, it takes Pycryptodome and it puts it into the crypto directory. But the problem is that if it goes into the wrong directory and it's linked to the path, it's not able to find the module. Okay. So let me put a note. For that step. Okay, so I'll re-upload this after this. I'll put down some notes there to troubleshoot it. Okay, so you got your RSA to work. We talked about private and public key. Now, once we have the key, we are going to encrypt the data with the keys. So RSA encrypt data.py. So on this one, similar to the one that you've seen before with AES, we are going to randomly generate our key in bytes. We are also going to use the public key from crypto and to import RSA. We are going to use AES because symmetric key can be used to deliver the public key. So we would use AES for RSA this way. So our data, we would have secret data, and that is encoding UTF-8. We're going to output this as encrypted data.bin file. So we're going to do a WB for write. The recipient key, we are going to import the receiver pen that we previously created in the last script. And we're going to let it read the public key from receiver pen file. Then we're going to generate a session key, and this is going to use the get random bytes. So here, this one is going to test to see if your Pycryptodome package would have that, right? Hopefully you don't have any issues with that. As we've seen that, that was the problem from the prior script. So once you have the session key, we are going to use PKC and we're going to construct a recipient key. And this is gonna now, we're gonna have an encrypted session key. So earlier, which is a session key, now it is an encrypted session key. So we are gonna use the session key now so we're gonna construct it as an AES session key. So here is where you would do the constructor. And we're going to use, anytime you use AES, you would use the AEX mode. And we're going to use that AES session key to encrypt the data. So for the data encryption, we're going to output that into a file. And we're going to close. So once I have this, I would run the script by invoking Python. And so if you have your Pycryptodome working, then it should run fine without any error. And when looking back at the script here, we are using AES and RSA. So the public key was read, and to generate the session key that was encrypted, we would use that to create the AES key for the data encryption. So you would have multiple level of security here. Okay. So as you run the script, we want to look at the type of files that we use in this particular script for encryption. And the key that we generated from the last script, which is the .pem file, we use that to create key in this script for the data encryption. Now the file that's output, if you look at the top, we output encrypted data.bin file. So the encryption is going to be stored here. Then we're going to take that file and we're going to try to decrypt it. Okay, using the private key. So on step 24, it's going to read the private key. And we're going to use the encrypted file that we've done in the prior step, be able to load the key and decrypt. So for the decryption, this is the script. And when you decode, make sure that we include the encoding system when we print. Otherwise, it cannot translate it to the appropriate characters. Okay. So then when we run the script to decrypt using Python 3, I would have secret data. So it properly decrypt there. And then I can go into my directory. I would see here is my encrypted data.bin. And then let me check this book here. Yeah, we didn't output this into a decrypted file, but we simply read the encrypted file. So for this one, the decryption. So it shows you that your PKI works. You use one key to encrypt, which is the public key, and then you use the private key to decrypt. And it would take you back to the plain text at the end after you decrypt. Okay. So we have the encrypted file. And we also have the key. That was the original from the prior script, and then we use this and the private. Okay. Any question? So for 25, screenshot, and then it asks you which file was used to decrypt, and then what plain text information is displayed. So now you often see that steganography is used with encryption. So the second part, I want to focus on steganography using stegano and stepic. So for part C, it talks about steganography and the art of hiding things in files and objects. So for Python module, we can use stegano. And we simply complete the exercises similar to the chapter where we would hide a string or a message in an image file. Now, in order for this to work, you should go and download a .png. Let me show you. So what I did was I just simply use Firefox, and one of the image that I use is I use the PNG from Wikipedia. So you can just search PNG Wikipedia or PNG file, and then you need to download it. Make sure that it is in the home directory or the same directory of your script. So I right click this and I would choose save image as, and then I would put it onto the same folder as my script. So originally we run everything from home, so you can browse to it there. So when I go in here now, right, I would have a dice. Okay. A dice PNG. And so when I apply this, the process for steganography, I'm going to save it as a second file, as you see, of that image. Okay, so what I did was I did this part, I save it. I was gonna do a wget command, but it takes a while to grab the image, so we're okay there. We'll just do the manual download. So coming back here, let's go to terminal. We would do a pip 3 install stegano. And I've done that. You can also say stegano version like this, so you can see which, oh, maybe not. Oh, you can't type. It's supposed to also pull the CLI, but maybe. Okay, so after we have the PNG file and we install Stegano, we're going to write a very short script. And I call mine Stegano IMG. It's where I'm going to do steganography in an image. So nano Stegano IMG. So we are going to import in LSV that allows us to access the method from that module to insert the text into the image or hide it. And we would use the hide method. So for the secret object, we're going to use the hide method, and we want to put it into our image, which is your first parameter here. I have a dice.png. So whatever the image name is, you would use that there. Make sure it's in quotation marks. And then the text that you want to hide, or the string, that will be the second parameter. After I've done that, I'm going to go ahead and click and try to save it. So I'm going to use the save method. So I'm going to save it. And to reveal it, I'm just going to then declare another object called clear message. And we're going to use reveal method. And simply that would be the image file name. So for this one, we save it over the same image. And I can print, right, as I reveal, and it should show me this. This is a secret. Okay. So the first 2 lines here allows you to hide. The next 2 lines allows you to reveal and show what that message is. Then we can invoke Python to complete the process. So now it reveals that this is the string that I hid in the dice PNG. And it's fairly simple. You can probably run this in shell instead of making it into a script, line by line, using Python 3 app. So we just need to make sure that we install our package. Take a screenshot, describe how this module is used to hide and reveal text in the image. Any questions regarding Stegano? This should be working fine. It doesn't have as many problems as your Pycryptodome. Now another tool that we can use is called stepic. And keep in mind that some of these also have interface and things like that, but you have to use another package to access the tool interface. And so we simply incorporate API through Python modules. So it is a lot easier for us to work with the API at script level. Now for stepic, because it is working with image, you also need to install pill or pillow. So you would do pip install stepic and then pip install pillow. So and I think this one you should be able to check the version. Yeah. Because it's a full application. And then you can do pip3 install pillow. Now, especially on Raspberry Pi, for a brand new Pi, even if you update it, it might not have pill. So you need to install this. So then we are going to do a nano, and I think I call that stepic img.py. Now, similar to what you've seen in Stegano, this one, we import image from pill, so that way we can work with PNG. We import in stepic. We're going to open our image file. So whatever your image file name is, you need to make sure that that's exact right there. So we declare an object called image, and it is instantiated for the image from pill. So that way it can read the image. Okay. Then we are going to declare a second object called image2. And this is going to allow us to hide the text. So the first parameter is our image, which is the last object that we instantiated. And then the second parameter is going to be our string that we want to hide. And we want to make sure that we encode that with UTF-8. Then on the next line, we are going to save it. So now on this one, I had saved it as a different file or a different image file. So I would have save, and the parameter, the first parameter is the new file name that you want to save and the type of file for the second parameter, because it is a PNG. Then now, after I had saved it with the hidden text, I want to access it. So I would then redeclare my image2 object, and I'm going to open and access the new file that has the hidden text. And I simply use the decode method. So I declare data, and I would use the decode method from stepic to reveal what's in the image. And then I want to print that out in plain text. So after that, I would save, and then I would invoke Python to run it. And there I have it. So my hidden text shows. So this is how you can hide text and image file, but there are a lot of different type of files that we can work with. So this is simply an example. And for stepic, I actually use the one that is in the notes. And for the first one, I use the documentation that they provided. Okay. So that works for us. So after you complete that, you can take a screen capture. You can explain how stepic is used in the script for steganography. And with that, we simply employ two methods, the encode and the decode. So as you can see with stepic, you would use encode and decode, whereas stegano, you would use hide and reveal. Okay, from LSD, which is a submodule. So you can use one or the other or both when you do steganography with Python. Any question? So that would finish up all 14 chapters from the beginning. We also did some review, and that allows us to wrap up the entire textbook. And I think this is a fairly decent book. It has some good example, right? And then I also supplemented from documentation and things like that throughout the exercises. So, okay, any question? Let me stop recording. Oh.